Hello everyone and welcome to this video. And in this one we're gonna be talking about test and test-driven development. And there won't be any code in this particular video, so it's just gonna be a bit chilled and it's gonna be focused at beginners. So if you're a 10x developer, this video is not for you. So this is the point where you quit the video, but before you do, click the like button, click the like button and subscribe. So we're going to be talking about test and test-driven development, which is a very common term in the software development world, and it's going to be focused at beginners, so you'd get a good understanding of why you'd need to write tests for your software applications, and also talk about the test-driven development approach. So before we get down to the technical jargons and all the whole buzzwords, although this video is not going to be having any buzzword, I'm just going to break it down to the way I understand it for you guys to also understand it. So the background of tests, how tests came about. Before automated tests, how software developers tested their programs were after they write the program, they would have to manually test it. So this approach could not scale because if you take, for instance, a software application like Facebook is quite big. So if you programmed something like Facebook and you were to test it, whenever you make a change in your software, whenever you add a new feature, you'd have to test every single part of your application to make sure that your application is not broken. So at scale, this approach is not really scalable because you have to always test every single part of your application. So aside from it being scalable, it also takes time because if you were to do manual testing, you'd have to be testing every single thing manually, clicking on buttons, waiting for feedback responses from the online resources, because when you build an application like Facebook, it has to be connected to the internet. So for you to fully and effectively test it, you would have to interact with the software application manually and wait for feedback and responses. And this approach does not really guarantee that you'd test 100% of your application because there could be some hidden corners you could you might skip. So folks back then now thought about how do we go around this deadlock. Then they thought about creating something called automated tests. So whenever you hear testing in software application, it's not really manual testing, it's automated test, which is just a bunch of scripts you write that test parts of your application. So if those tests, so you have to like write the test, then if the test pass, it means that you've effectively tested that application. And if you change part of your application, you run your test all over again to see if it's broken. So that's just a brief background of how the whole concept of automated testing came about. So you don't have to rely on humans to manually test your application. Instead, you write scripts that kind of like projects the features you want to actually achieve. Then you write your code, then you test it against this test to see if it actually passed. So what are automated tests? So I don't want to use any buzzword in this video. So before this video, I made sure I did not research any term, so I would not have kind of like a very complicated definition. So everything you're just going to be getting in this video is just my own understanding of automated test and test-driven development. So now automated tests, like I said, whenever you want to build an application, your application would have a list of requirements that you intend to achieve. So manually, these are the requirements. So you have your application should be able to log in the user. That's a feature. And it's also a requirement. You should be able to get the user's feed. So imagine if this was a social network, you can also create posts, delete posts, and users should be able to follow each other. So these are the requirements. So how do you know that your software has fulfilled all these requirements? So test is just the code version of your software requirements. So software requirements could just be a document with list of features and the stuffs you intend to achieve. But from the programming aspect, this is not sufficient enough because this could be really vague. So when you have in a requirement, probably the client gives you and you stay with your project manager and you guys list out all these requirements. You have to write it in code to be able to, because your software is not a bunch of text, it's not a bunch of to-do lists. No, your software is actually a program that is being run by code. So automated test is the code version of your requirements document. So you have a requirements document, then programmers don't, as in software programmers don't really understand, they understand this document, but if you want to have the code version of your requirements document, you do it in what test. So now, for instance, login user is just a single requirement, but if you want to write the test, this is how it will look like. This is just a dummy test. So you have the test you want to execute here. We won't be talking about the details of all this describe and test, but you have a test. And what does this test, what should it do? The test should log in user successfully. So whenever you call this login function and you pass the correct username and password, you need the result of this function to be what? True. So if it is true, it means that the user has successfully logged in and that feature is correct. So a brief recap, you have a requirements document. A test is the code version of your requirements document because that is the only way you can be able to have confidence that the code you've written matched the requirements given to you. So automated test, yeah. So how do you relate test with your code? So I just had this little table to just show you how you could have a good understanding of what tests are. So a test shows you what you want to achieve, which are your requirements, which is what I just explained from the previous slide. Then your code implements how to achieve these requirements. And also, a test is like a map of your intended destination, then your code is the journey. So your destination would be, so if you are doing something like TDD, which I would explain in future slides, you have a list of what you want to achieve. Then your code would have to make sure it abides to those list of requirements in code. Then also, it is like a contract. A test is like a contract, which your program must abide to ensure correctness. Then your code is set of instructions that fulfills this contract. So the whole idea of testing, if you don't want to complicate it or if it's a bit misleading or confusing for you, just imagine test to be your requirements documents, a list of requirements your software is going to pass to make sure that you have completed the intended vision of your project. So you don't have to complicate things. So test is just like a requirement document written in code. That is just it. And you're gonna see how everything comes together as we progress in this presentation. So now what should you test? Because now we've been talking about requirements testing, why testing is good and all. So what should you test? You should test every code you write. You should test every code you write. Now, I'm not saying you should do this exactly every single if-else statement you should test. You should not test stuff like if-else statement. Instead, you should test stuff like the functions you've written. You should test something like your widgets. You should test that as if you're using Flutter. You should test your components. That is if you're using something like React. So you shouldn't test. You should also test edge cases. So for instance, you have a simple application whereby, or let's use the one we've been talking about. You have a login functionality. So you want to be able to test different scenarios in that login functionalities. You don't just test if the login is successful. You also test if the login fails. You also test if the user passes an incorrect email address. You also test if incorrect email address in the sense that probably you write an email address without the @ symbol. You can also test if the username is missing or the password length is not up to the required minimum character of 8. You can also test just multiple scenarios you want to achieve. So you just be answering the question of what if. What if the user omits his username? What if the password is not up to the required length? What if the email is incorrect? So you try to answer all the whole type of what ifs you could actually get. Then for a UI application like Flutter or React, you should also test what if the user logs in and there's no internet if the user tries to log in and there's no internet connection, for instance, you should display a particular message or dialogue on the screen. So you could also test if that dialogue is visible when the internet connection is when you don't have internet connection. So you should test all these things. So for what I've said, you should test functions, you should test classes, you should test components, you should test widgets and all those things. Everything that you feel that are going to be playing, everything you feel that's going to be playing a very important part in your application, you should test it. And if you write a very good test, it should also cover your code branches. So what does that mean? It should cover your if-else statements. So you would see that as we progress. Then what shouldn't you test? You shouldn't test library functions. They should be tested by the authors. So for instance, if you are using a library like _JS, if you're from a JavaScript environment, or if you're using a library like the HTTP library in Flutter, you should not test if the get function is going to be doing what it expects, what it's supposed to do. Instead, you leave that to the tester, because if you check GitHub, on GitHub you should see the libraries. There's something called code coverage, which we're going to be talking about. So a good library should have a very good test coverage. It should have a very good test case. So you should not be reinventing the wheel. The authors of this library ought to have tested their libraries and their functions. So you shouldn't go and retest it again. If you use a library whereby they don't test anything, that would be a red flag for you that you should probably stay off such a library. Another thing not to test would be time-consuming tasks. So what are time-consuming tasks? For instance, now you want to request data from an online API in your application. Your application is going to be making use of an online API. So now that online API, as long as it's going to be connected to the internet, it's going to take a couple of seconds to actually get that feedback. And for your test, you want your test to be fast. So instead of waiting for that feedback, what do? You create something called a stub. So stubs returns expected data. That is for unit and integration testing. We're going to be talking about these two things. So just forget about that for now. So for that time-consuming task, instead of you actually testing it and waiting for that feedback, because most test runners, the stuff that runs your tests, most of them times out after, I think, 4 seconds. So if that your time-consuming task does not complete before that 4 seconds, there would be a timeout and your test would fail. So your test was actually correct, but the timeouts elapsed and it will be giving you false positive. Or is that false positive or false negative? I mean, your test was supposed to pass, but because of the timeouts, you had a failed test. So now I've been talking about stubs and mocks. If you've done any testing previously, you would have come about something called mocks. Now, there's a subtle difference between stubs and mocks. So, stubs are just objects that hold some predefined data. So that's your time-consuming task from the API, you put it in a stub. So it's going to be holding that data. So whenever you make request of that data, instead of it connecting to the online resource, it's just going to return that data that you've defined in that particular object. So that's what the stub does. It just holds that predefined data and values and returns whenever your text expects that function to actually return the data. So your test won't be waiting for that online API. So if that online API was just supposed to return the username of the logged in user, you just have a stub. In the object, you say username should be equals to John. So whenever it is requesting that username, it should do what? Return John instead of contacting the online API. So you're kind of like cutting, I wouldn't say cutting corners, you're just kind of like creating an object that stores this data. So that is stubs. Then mocks on the other hand are just objects that keep tracks of calls that they are expected to receive. So if that is not explanatory, I'll come again. So mocks are just objects that keep tracks of calls that are expected to be received. So for instance, now when you have a stub that is returning, you have a login function. For instance, you have a login function, and you want this login function to return true. So instead of waiting or connecting to that online API, what do? You create a stub that's going to be returning true if the whole stuff is successful. But inside that login function, there are multiple things you are going to be doing. So that inside the login function, you could be connecting to an online API. So that online API, you could create a mock of that online API. So inside that login function, you can now check your mock. When we do this in code, you'd see what that means. But you can now check if this certain API was called. So that's what mock does. It just keeps track of these calls. So you now check if this certain API was called, or if it was called probably once, or if it was called twice. So when you have the stub returning the object, you have the mock keeping track of all the whole calls inside that function. So you can now be able to test if that particular API or if that particular function or request was called. So that's just the brief difference between stubs and mock. So stub returns objects of what you should expect from a time-consuming task, while mocks keep tracks of calls of certain resources. So you can check if the login API was called once or twice. So probably if the login failed, whether you should retry. So probably the max amount of retries could be 2. So from your mocks, you could be able to say, verify that this login API was called maximum of twice. So that's how you'd do something like that. And I'll link an article that talks about differences between stuffs like stubs, mocks, fakes, and stuff like that. It was written by Martin Fowler. So now you've written your test. How do you know? How do you have confidence in your test? So there's something called code coverage. I'm going to be talking about different terms used in the whole testing environment in this video. So what code coverage simply means is when I run my test, what percentage of my code is executed? So this value shows how much of your code is executed by the test environment. This number does not necessarily mean quality test. So now you have an application like, for instance, Facebook now. When you run the tests, because when tests are just bunch of scripts to just verify that, to verify your requirements in code. So now what code coverage simply means is whenever you run your tests, it's going to check the test that you've actually written. Does it cover most areas, or how many parts of my application code does it cover? Because your test code is different from your application code. So code coverage just simply gives you the feedback, a report of how the span of your text, how substantial the test you've written is. So now, if you have a code coverage of 100%, that does not really mean that you have a quality code. And that is very, when you start writing tests, you get the hang of what this simply means. So you could have a test that mounts a particular widget or a component. So in testing, in mounting, there are two types of mounting. You can do something called shallow mount, and you have deep mount. So for instance, if you use something called deep mounting, like in Flutter or React, when you mount your components or your widgets, every other component inside it, because you know, if you've done your React, you know that components contain components. For Flutter, widget contains other widgets. So if you do kind of like a deep mounting of a particular widget of a page, every single widget inside that widget would be mounted it would have kind of like the complete tree of that particular widget. So now when you run your tests, and probably you're just testing the topmost widget, but when you run your test, and if that widget is the only widget in your application, when you run your test, it is going to be giving you 100% code coverage, because that topmost component has all the whole children components inside. But giving you a code coverage of 100% does not mean that you've tested those children widgets or children components. So you don't always have to rely on this code coverage of 100%. You should, as you start writing tests, you'd be getting a hang of what quality test simply means. And quality test just simply means covering different cases, even edge cases of answering the what if questions I told you about. So don't be really, if you have, someone can have a code coverage of 100% and someone else can have a code coverage of 80%. Meanwhile, the person with the code coverage of 80% test might be more quality and more substantial, covering useful cases in the application. So you just have to get used to this term called code coverage. It does not really mean if you write a code and you have a 90% test coverage, you shouldn't feel guilty and spend time trying to reach 100% code coverage, because at the end of the day, you'll be spending time writing tests without even covering your main app functionality. So as time goes on, you get the hang of when you should actually stop writing unnecessary tests. No test is really unnecessary, but some tests can be unnecessary. This stuff, there's no real strong way to explain it. It comes with experience. As you start writing code, you'd be able to differentiate between the not so good test and quality test. So now, type of tests. There are different types of tests, and we have the three major ones. Depending on the framework or environment or programming language you're working with, there are different names they give this stuff, but these are just the generic name. So we have the unit test, the integration test, and the end-to-end test. So the unit test is just testing a single independent isolated code in your application. So when you say independent and isolated code, most of the time you're talking about a simple function or a simple class, something that is just isolated and can exist on its own. So for instance, now you could test a function that converts all lowercase, that converts a word from lowercase to uppercase. So that single function in which you just wrote, you can actually write a test for that function on its own. So when you call the function, you pass in a string of lowercase characters, and you should expect the result to be a string of uppercase character. So that single unit is isolated and it can work on its own. So some of the things that can work for unit text are functions, components, and widgets. And the order in which I arrange these things are very important. So the smallest test you can write for any software application is the unit test, followed by the integration test and end-to-end test. So after the unit test, the other type of test in the pyramid or in the hierarchy is the integration test. So now integration test is just probably testing two or more units together. And most of the time when you test two or more units together, which is probably two or more functions on a class and how they interact, that could be a combination of one or more units of the application. So for instance, a simple example of an integration test would be that function I just told you about now that converts lowercase characters into uppercase characters. An integration test for that would be a component or a widget that has a text box or a text field with a submit button. So you could write tests for that entire component or that entire widget. And remember that widget makes use of what? The function, that function that has been previously unit tested. So that widget is going to be making use of that function that takes in the lowercase character and converts it to uppercase characters. So if you were to write integration test for that particular feature, it is going to be the components you'd be testing. So you'll be testing the text box when you input something into the text box, and when you click the submit button, it should convert everything there from lowercase to uppercase. So that is just basic example of integration test. So you're testing one or two units together to see if they work as expected when you combine them together. So the next one is end-to-end testing. So this is just testing the wider scope of the entire program. So what that means, most of the time, end-to-end testing is just like it's going to be simulating the end users. It's going to be simulating the end user using that your application. And most of the time, most of the time, end-to-end tests are carried out on actual devices. So if it's for a mobile application, it will be carried out on a mobile app. And if it's on the web browser, it will be carried out on the web browser. So this is going to be simulating the entire flow of the application. So nothing will be mocked most of the time. So most of the times, you'd have your browser open and you have this end-to-end test library or application actually interacting with the real application on your web browser. So you are not testing a single unit. You are not testing a unit and some other UI feature. What you are doing is that you are testing, for instance, now you can write an end-to-end test that tests the flow of your login system. So when you write the script, it is going to be doing what? Interacting with the web browser. It clicks on the username text box, fills it up, clicks on the password text box, fills it up, click the submit button, waits for it to send to the API. So here you are not mocking. You are simulating how the user would actually use this application. You might say, why would you do this type of thing when you can manually test it? Okay, if you manually test it, one of the things is that it could be boring and monotonous tasks. But when you write a script that actually executes all this stuff, you can be able to check your code coverage. But if you are doing manual testing, you wouldn't be able to verify that you've tested 100% of your application. So in hierarchy, unit test is the smallest, followed by integration test, and followed by end-to-end test. And you have, each of them has its pros and its cons. So unit test, since you're testing a simple function, it's always fast. It is always fast as compared to integration test and end-to-end test. End-to-end test is the slowest because now you are interacting with your application and you are waiting for API calls and feedbacks. But remember, in unit test, you can mock all those stuffs. You can create stubs for them. So end-to-end test is the slowest because you have to be waiting for all the whole flow and all the whole clicking and all waiting for responses and feedback. Now, for unit test, you have low confidence. So what does that simply mean? Low confidence simply means that if you test a function that converts lowercase characters to uppercase characters, you're going to be having low confidence because at the end of the day, having that function work does not mean that your application will work. An application contains multiple components. It contains multiple parts. That function is going to be used by a component. That component is going to be contained inside another component. And that component could also have a route or a link or a path whereby you have to click to access that. So if you only write unit test for that particular function that converts lowercase characters to uppercase characters, you would have low confidence because that unit just exists on its own. You've not checked if that unit can effectively interact and produce the expected or the desired result of your application. So you'll be having low confidence because it is just, look at this word, isolated. It is on its own. It does not really tell you that the purpose of your application has been achieved. So you have low confidence. Then integration test, you have medium confidence. Why? Because now you've integrated that function with a particular component that has a text field and a button to submit that. So you have medium confidence because now you can say, okay, this unit, this function can now interact with the text field and this submit button and it's giving me my expected result. But your application might be bigger than that. Your application might actually have a user login page whereby you'd have to log in to be able to use this feature. So now with integration test, you have medium confidence because your units, the function and the text box and the button are interacting very well and working together. So you'd have a little bit of confidence that yes, at least my one of the key requirements has been achieved. Then you also have highest confidence here, whereby you are now doing an end-to-end test in which you log in the user interacts with the text box, fills in lowercase characters, clicks on the submit button, the user gets the dialog saying you have successfully converted these lowercase characters to uppercase characters. Now you have highest confidence because you are testing your application as a complete pack. You are testing every single interaction whereby your end users would be using, or how your end users would actually be using this application. So you have a full confidence that yes, I've tested it from top to down. I've tested from the login to the text field to the button to the dialog to the feedback to the conversion. I am very confident my software meets the requirements. But as with everything, it has its pros and its cons. So for unit tests, there's really no very low maintenance and low dependency, because most of the time you're testing a function. This function might not be dependent on an external library. So it's very easy to maintain, because whenever you want to update the test, the test is always small. You just go to that particular function unit and do any updates you want to update there, because it's just one isolated unit. Then for integration test, you have medium maintenance, because now you're maintaining the individual parts that make up this integration. So most of the time it might just be one or two units. So you just have to check. So if, for instance, this integration test fails, the only thing you'll be checking would be that component or the widget and the corresponding functions that this widget actually uses. So sometimes it could be one, it could be two, but you just have a medium scale maintenance because it's not really that big. Then for end-to-end tests, it has the highest maintenance, because right now you're working with the complete application. So if you're testing a mobile app, you are working with the complete application. So if your end-to-end test fails, that is going to be a bigger problem compared to your unit test. When your unit test fails, you just go to that function and do the checks. But when your end-to-end test fails, it could be multiple reasons. There could be multiple reasons why it actually fails, because now it's treating your application as a whole. It could be as a result of no network connection. It could be as a result of one function not returning the expected value. It could be as a result of the dialog not popping up when it's supposed to pop up. So to maintain this is quite large. Because you're testing your entire application. So the fault of why your test fails could come from multiple functions. It could come from multiple widgets or multiple components. So you can see it's quite high to maintain. So now, from everything I've just explained, the next question I believe some of you will be asking is, so which test should we actually write? Should we write more of unit tests? Should we write more of integration tests, or just do end-to-end testing our applications and everything? So the answer would be it depends. But for a good test case should have as many unit tests as possible. I'm still going to explain why. It's going to have as many unit tests as possible. It's going to have a medium amount of integration tests and a low amount of end-to-end tests, because end-to-end tests are quite costly, and if it fails, there could be multiple reasons as to why it fails. So most of the time, if you have a very good coverage on every single unit you've written, so if you've tested every single function and you've written integration tests that combines the use of this function with your component and with your widget, and all those tests pass, then if you now write end-to-end tests, the possibility of it could also fail, but the possibility of actually maintaining it becomes easier, because at the end of the day, you've tested all units, you've tested that unit integrating with other part of the component of your app using integration test. Then you are now checking the end user flow, because many applications that don't actually do end-to-end tests, because they believe that if they've done the unit test and integration test, then the end-to-end test can just be an added luxury. So you should write more of unit tests, then medium integration tests, then very minimal end-to-end tests. So that is how you should flow. But if you are using something like React, like me personally for React, I write more of integration tests, because React is made up of components, and I could actually test a component and check the UI if it outputs a particular result, and my test coverage would show a high number, because if it does not attribute the actual result, I can easily track where that problem is coming from. So I write more of integration tests for React JS applications. But if you don't have time, end-to-end test can just be an added luxury. I'm not saying it's bad, but most of these end-to-end test providers are actually paid. Like Cypress is actually paid, although you have free and you have some limits and everything. But this is just it. Flutter also has its own Flutter driver. Flutter driver is just Flutter's version of Selenium WebDriver. Selenium WebDriver is what do they call this thing? Headless browser testing, blah blah blah. You just do your research and check about that. But you just have to have, if you were to write, like personally, if I were to write, I could write more of integration tests if I have a very tight deadline. So that is just it. As you write this stuff about test, it comes with experience. There's no, as you start writing test, you'll be able to find the one that works best for you. So this brings us to the next stage. At what stage should you write your test? So there are different approaches to actually write tests. There is test-driven development and there are other types, but I just put a not test-driven development here. There's behavior-driven development. There are so many buzzwords in all this stuff. So now the question arises, when should you, at what stage should you write your test? So to do this, let's take a very simple example of, we want to create a robot. This is just a very basic, it's fictional example. So test-driven development says I would write my test before I implement my code. If you are not using test-driven development, let's say you now say you want to write maybe after the code implementation, or you could decide not to write any test and you test your robot manually. Now, for test-driven development, how the flow actually works is this. You and your team, you sit down and you take the requirements. Okay, I want to make a robot that actually does this, maybe that creates a load from point A to point B. So you take the requirements and you write the whole test. You write all the whole possible cases of what you want this stuff to achieve. So for instance, you could say the robot should be able to stand when I say the word stand. The robot should be able to do this when I send this command. The robot should be able to do this when I press this button. Remember, all these stuffs are requirements, but now you are now writing a code that checks that if the actual code I'm going to write at the end of the day is correct, every requirement I've created in this test should pass. So test-driven development makes the argument that you should write this test before actually writing the code, and it comes with some benefits. So for instance, now, like I said, you've written all these whole test cases of what you expect this robot should be, or what this robot should behave like. So you write every single thing down, you write every single test case down before you actually build this robot. So as you are building the robot, so initially when you write all this test case, all the test is going to fail. Everything is going to be red because why? You've not actually created the code for this robot. So when you're doing test-driven development, there are 3 steps. There's the red, green, and refactor. So at the initial stage, when you've written the test, all your test is going to be red. They are all going to fail. Then what do? You start writing your code to make sure those tests start turning from red to green. Green means that they've passed. So it means that the robot you're actually creating is conforming to the requirements of your team written through the test. So at the red stage, you write all your whole tests, they all fail. Then you now start building your code to be able to turn these red flags to green flags. And when you do this and you turn all the whole reds to greens, it means that your software is adhering or conforming to the tests, is conforming to the requirements you guys have written in code. That does not really mean that your application would work as expected, because definitely there's always bugs in application, but it also shows that your code has conform to the test you've written. So that is why it's always good to write quality tests. So now the advantage of test-driven development is that when you write your test before you write the code, this is when you kind of like brainstorm, you kind of like think about multiple scenarios. What if this thing happens? What if the robot's battery is low? What should happen? And I give it a task. What if? What if? So now you are free spirited. You're just writing multiple, imagining different scenarios whereby these robots would be used, on how it will be used. You're just writing these test cases. Then you now write the code. But if you did not do test driven development, you write the code, and after you've implemented the code, you now want to write tests. There's a possibility that you are going to be biased, because now you'll be writing tests that would just conform to the code you've already written. So now if you've written code that's going to be doing 1, 2, 3, 4, 5 things, you would try to be writing tests that would conform to the code you've already written. So there could be an element of bias whereby you might not write enough test cases. But remember what I told you about test-driven development. If at the beginning stage you're just writing multiple tests, you got in your team are discussing, okay, this is what if this thing happens, this is how it's going to happen, this is if I press this button, this is what I should expect. If I press this button and the battery is low, this is what I should expect. So with test-driven development, there's a possibility of writing more tests that cover edge cases. But if you write your test afterwards, you could be biased and you might not write quality tests. Remember, everything I'm saying, take it with a pinch of salt, because sometimes test-driven development is good. Also, I would also make mention of what I do when I code React projects, because for my React project, I write depending on the components, because one thing about testing UIs is that sometimes the end goal of the UI you're actually creating is not predictable. So sometimes I write the test immediately after I build the component. But with something like React testing library, whereby you could write tests that does not really depend on implementation details, you can actually do test-driven development. It is not a must you should do test-driven development. I'm just talking about the different scenarios. Another benefit of test-driven development is this. There's something called YAGNI. You ain't gonna need it. So the beauty of writing test-driven code is that when you write your initial test and it's read, the only thing on your mind, the only thing you are trying to work towards is that I want to turn my test from red to green. So that's going to make you just focus on turning those tests from red to green. So you would not be putting unnecessary features over implementing premature optimization and writing code you might not need, because at the end of the day you just want to turn those red into green. When it turns into green, it means that your code has passed the test. Every other thing is just refactoring and optimization and just an extra add to the project. So back to the red green refactor. So when you turn your code from red, it goes to green. It has passed. You can move on with your project, or you could simply come back and do what refactor. So for some instance, the code you've written, out of the codes you've written, you can actually make out a function that is being used by 2 or 3 widgets, and you could now make your code better. Then when you make your code better, what do? You go back and you run your test. So if your test shows green, it means everything is cool. So that is just the whole idea of test-driven development in a nutshell. So everything still depends. Some folks write their test immediately after they create their components or the functionality. That can be also fine. The main thing, for me personally, I don't care whenever you write your test. The main thing is that whenever you're showing me your code, you're showing me your code with your test, and your test should cover multiple cases. Your test should be quality. And how do I know if your test is quality? That comes with experiences. That comes with asking the questions of what if. So I'll go through your test case and see if it answers multiple what ifs. So that is test-driven development and not test-driven development. There's BDD, there are other ones. Then no test, that's the manual one. That is if you don't write tests. Well, fine and good for you. And the problem I feel, the problem I think that most folks don't really do test-driven development is that most senior developers, let me not say most, so many senior developers and industry veterans just and companies just tell you this you should use TDD. We use TDD in our app. That's test driven. They just try to force this whole test driven development stuff in your face, and you've not really like found out like why should I write my test before I write my code. It's kind of like really confusing for beginner developers because everybody is saying TDD, TDD. You go to job sites and you read the requirements of the developers for the job post, and they say you must know how to implement TDD, but nobody really tells us like this is the advantage of TDD or this is what TDD actually does. Personally, me, I don't just follow the crowd and do what everybody is doing when they say this is the in thing in town, that this is what you should do. I actually try to see and think through things. Do I really need this? So about TDD and writing tests generally, because previously, years ago, I don't write tests because I believed in testing my code manually. But I learned this the hard way because if you don't write your test before you write your code or immediately after you write your code, if you're doing it at the end of your project, it can be very frustrating because now you start writing so many tests. It now becomes like work. It becomes big work for you because you end up being frustrated. But the beauty about test-driven development or writing your test immediately after you've implemented your code is that it is iterative. So you don't have to create a separate branch if you're using something like Git and say for test or something like that. As you commit your code, you are committing it with the corresponding test. So you're building your project iteratively. So at the end of the day, if you've written code up to 80% of the requirements and you've written a very good test case, it means that if you've completed your project up to 80%, there's a high possibility your code coverage could be 80% or somewhere close to that, probably 60 or 70%. So at the end of the day, when you've done with your project, there's a possibility of having what, 100% code coverage or something close to. But if you don't write test at the end of the day or at the end of the project, you start writing test, you would try to be, when you see your code coverage at the beginning of probably 10%, you will try to be getting to a reasonable mark, and this can be really stressful on you. So the whole concept of writing tests comes with experience. I learned it the hard way, but I'm making this video for you guys to just start, for you guys to imagine different scenarios whereby writing tests could be beneficial. So which is better? I think I think I just answered that question from the previous slide. So it all depends. So for instance, if you charge your client like $10,000 for a website or for a web application, and the client tells you that he or she is going to pay you 1,500 US dollars, then don't write test for the client. So that's one scenario. Okay, I'm just joking. But seriously, so which is better? Like I said, it depends. So sometimes you don't have to be a test purist. I think that's the word. So sometimes you have a very tight deadline. You have a very, very tight deadline. You're supposed to the app is supposed to go live in like 3 hours time, and or like 2 to 3 hours time, for instance, and the whole team is just waiting for your code or something like that. Then you spend the next 1 hour 30 minutes doing TDD and writing your test cases. At the end of the day, you spend 2 hours writing test cases, then you now spend 30 minutes trying to squeeze up to write the code. At the end of the day, the code is not complete. The client sees incomplete code, and that brings like shame to your company. But at this type of scenario, you could just write, because this also comes with experience. some codes you write would work as expected, but tests just give you that extra confidence, that extra assurance that, okay, I can actually go to bed at night and sleep. Then if something happens, the first question would be, could the problem be from an external resource or an external API or something external? So writing tests just gives you confidence to sleep at night. But this scenario of where you have a very tight deadline, probably 3 hours to complete what you ought to have done, you could just write your code first of all. Then so many tests, to be sincere, so many code goes into production without writing tests. Then when the code is live, then the developers actually now write the test to check if those things are there. But the end users, most end users won't see this glitch probably until 5, 6, 7 hours, sometimes 2, 3 days, and you have that grace to actually write the test to match up that if there's any changes, you can actually correct the code and push back to production. So you should also be smart about when to write tests, tight deadlines, very tiny projects that you just have to put out there, hobby projects. So it all depends. Sometimes you can push to the production and you could come back and write the tests. It all depends. But I think I've just highlighted some advantages of using the test-driven development. So now I think there would be a next video whereby I would show test-driven development in a very simple, very simple and basic application whereby everything we've talked about, we would actually put it into practice. I think this will be optional. It all depends. If you guys want to see this video, you let me know. So I could either do it in React or Flutter. So you also let me know in the comment section. If I don't see any comments or anybody saying they want something next, then that means there won't be any next video. So I believe I've demystified the whole concept of automated test and test-driven development. Like I told you, tests are just simply your requirements in code. So it's only when you have a code checking through your requirements, you'd be able to have confidence that you are adhering to your requirements. And also test-driven development, which is making tests drive your development. So you write your test, then you develop towards that test you've written for it to pass. So that's the whole concept of test-driven development, and in this video we've covered multiple terminologies in this, and I made sure to avoid buzzwords. So everything I just explained in this video is just based on my experience of writing tests and doing test-driven development, and I hope it was helpful for you. And like I said, it's focused on beginners. So with this video, I hope you have a better understanding of how tests are, what they do, and what test-driven development is all about. So thank you all for watching, and I'll see you in the next one. Bye.